Hello everyone. So today we will discuss the Gauss divergence theorem. Basically it's a topic of mathematical vector space, but we are discussing here because it is very important theorem to evaluate the field strength of any force field in the branch of physics. What does this theorem tells? This theorem tells if any source X is radiating some vector field outside or some vector field V is diverging outside the source X, or it is converging towards the source X. In both cases, the flux of this field around a closed surface, like it is here and here also you can consider some closed surface, the flux of this field around this closed surface S, it is proportional to the source. Now you see what is the flux. Suppose you take here, this vector line is coming outside this surface, and here you take surface element, this ds. So ds vector will operate perpendicular to this surface, and suppose v is making an angle theta with this surface element, then v dot ds is the flux of this field over this surface area element. If you integrate over all the surface, you will get the flux of this field towards the closed surface S. As per this theorem, this must be proportional to X. Similarly, the case here also. Here also you can integrate all over the surface. This must be proportional to cos or source X. This implies that overall flux means closed surface integral V dot ds. This must be equal to Kx. K is the constant that is decided by what type of field you are taking under consideration. So it depends upon the nature of the field. So this is the mathematical theorem what I have to discuss. Now mathematical part is over. Now we'll apply this theorem in determining the various types of force field available in nature. After discussing the Gauss divergence theorem, now we will see the application of Gauss law for determining the electrical field and gravitational field. You are already aware that in electric field calculation we apply Gauss law, but today I am offering you the unique methodology to find out gravitational field intensity using Gauss law. This you may not find in other books, so just listen carefully how we will apply Gauss law in gravitational field. So in case of electrical field, in case of electric field, a positive charge Q is kept here and electric field of lines are diverging outside from this charge all around. You have to find out the electric field intensity at a distance r from this charge Q, say at point P. So you assume that electric field intensity is here E. What you will do? Considering this point P on the circumference and charge Q at the center, you draw a spherical Gaussian surface all around. So what the Gauss divergence theorem was telling? Flux of this in E vector all over the surface means surface integral of E dot ds is proportional to source of the field, that is Q. Okay. Now here if you will take the surface element, that is ds, correct? So ds vector will also be parallel to E. Why? Because it's a spherical symmetry. The electric field lines will be radial and the surface element is also radial, hence both are parallel for this elemental area. So for this elemental area, what you will get? Surface integral EDS. Why EDS? Because E dot ds is equal to EDS cos 0. ds is also in same direction in which E is operating. So this must be, here I convert this proportionality to equality. This must be equal to Q by epsilon. So epsilon is the permittivity of the medium. Correct? So here in case of electrical field, the constant is 1 by epsilon that I have introduced here. Now you have to do the surface integral all over the surface. If you see all over the surface, E is constant. Why? Because the surface point is equidistant from the charge. So this E can be considered throughout the integral constant. Hence it will come outside. So E surface integral ds is equal to q by epsilon. And this implies that E, once you integrate the surface area throughout the spherical surface, you will get the value of 4 pi r square. Surface area of this Gaussian surface. This must be equal to q by epsilon. Hence, electric field intensity will be equal to 1 by 4 pi epsilon q by r square. So that is our desired formula. You have already studied, but this time I have derived using Gaussian. Now you see carefully this gravitational field calculation using Gauss law. But listen carefully, because you may not get this explanation in books. Now here given a mass m and gravitational field of lines are converging at this mass from all around. Because this mass have its own gravitational pull from all sides. We have to calculate the gravitational field intensity at a point P r distance away from this mass. So here the field intensity, gravitational field intensity will act in radial direction towards the mass, and this field is nothing but acceleration due to gravity. So here acceleration due to gravity is equivalent to electric field intensity in case of electrostatic field. In the same manner, here I will consider a Gaussian surface which is spherical, having mass m at its center and the point P where gravitational field intensity is to be calculated at the circumference. Correct? So again, here if you take area element here, so in this area element, ds vector and g vector, they will be parallel to each other, because ds vector will be perpendicular to the surface. So as per the Gauss law, surface integral of g dot ds means flux of this gravitational field intensity all over the surface. This must be proportional to cos of this field. Cos of the field is what? M. So again, since g and ds are parallel, so here it will convert as g ds. Now I convert into equality. So here for equality, you will take constant 4 pi capital G and M. So you see the difference. In gravitational field, the constant of equality will be 4 pi G, where capital G is the universal gravitation constant. In electrostatic field, the proportionality constant is 1 by epsilon here. So what does it conclude? Means 1 by epsilon is equivalent to 4 pi G in gravitational field. Means here constant in electrical field 1 by epsilon will be there. Here constant 4 pi G will be there. In electrical field, what role charge Q is playing? In gravitational field, same role mass M is playing. And in electrical field, the intensity is represented by field intensity vector E. In gravitational field, the field intensity is represented by acceleration due to gravity G. So once you proceed, so again you see this G will be constant all over the surface. Same fashion here, because all point on the surface is equidistant from the mass, so G can come outside. So G surface integral ds is equal to 4 pi G M. So G, and this will become 4 pi r square is equal to 4 pi G m. So 4 pi is cancelled away from 4 pi and G is equal to Gm by r square. So this is the formula for gravitational field intensity due to a mass m. So you see the formula for gravitational field intensity due to mass m you will get same as by other conventional method. So I hope you got a unique method to find out the gravitational field intensity due to mass m, and it will be helpful for you. So that's all for today's video. If you like this video, please give a like button and please subscribe my channel. Thank you very much.